Hello student, welcome to our the channel The Physics Point. In the previous lectures, we have just started discussions of the second topic of the 12th standard physics, that is mechanical properties of fluids. In the previous lectures, we have just introduced what is the fluids and some properties of the ideal fluids and normal fluids. In these lectures, we have started discussions of some different points, that is the pressure. What is the pressure? Definition of pressures, equation or the formula of pressure, as well as we just discussed some smallest derivation with the help of good neat and labeled diagrams, and as well as we started discussions of the atmospheric pressure. These are the types of pressures. Okay, a pressure, what is the definitions of the pressure? A pressure, a normal force exerted by the fluid at rest per unit surface area which are under the contact of that fluids is called as pressure. The normal force, the normal force exerted, the normal force, that is F, exerted by the fluid, the normal force exerted by the fluids on the unit area, on the surface of unit area, that is A, of contact, which are under the contact of contact, is called the pressure. The pressure is the normal force. The pressure is the normal force exerted by fluids on the surface area, on the unit surface area or surface of unit area in the contact is called as pressure. The pressure, the force exerted, pressure denoted by the letter P, pressure P is equal to force exerted, that is force exerted on the unit area, that is A. And the pressure is a scalar quantity, it does not have any directions. This is the scalar quantity. Pressure is the scalar quantity. The definition of pressures, equations of the pressures, as well as what is the unit of pressure. When we just know some knowledge about the equations of the pressures or definitions of the pressures, then we will calculate it. What is the, we just get the idea what is the units of that pressures. Force, the unit of force is a Newton, and a unit of area is a meter square. Newton per meter square is the unit of the pressures, or the proper units of the pressure is Pascal. The proper unit of pressure is Pascal. Some other units we are just discussing here, that is 1 bar is equal to 10 raised to 5 Newton per meter square. This is the unit of the pressures. The pressure, the normal force, जे फ्लुइडचा नॉर्मल फोर्स नॉर्मली ऍक्ट होतं, कन्सिडर करा हे अशा पद्धतीने एक सरफेस आहे, यावर परपेंडिक्युलर, नॉर्मल इट मीन्स परपेंडिक्युलर फोर्स एक्झर्टेड, इकडे फ्लुइड भरलेला आहे, and this is the one of the vessels, consider there, and the normal force exerted on the surface of container or the surface of any pots. Normal force, perpendicular force of the surface. ओके, एक्झर्टेड पर युनिट एरिया, एक युनिट एरियावर ते म्हणलं जातं प्रेशर, त्या फ्लुइडचं त्या सरफेसवर. देन द डायमेन्शन्स ऑफ द प्रेशर इज, दॅट इज L raised to -1, T raised to -2, M raised to 1. This is the dimensions of pressure. Okay, definition, equation, units and dimension, these are the 2 marks questions. What is the pressure? Explain the pressure with the help of suitable units and dimensions. Okay, the next, just to discuss one smallest derivation here. Pressure at a point due to liquid column or liquid due to pressure at a point due to liquid columns. Just drawn one of smallest diagram here and explain this diagram. Consider one of the vessels and they filled with, this vessel is filled with liquid. The vessel is filled with some liquid and we are consider the density of the liquids. A vessel filled with liquid having density. The density of this liquid is having density that is rho. Rho is the density of that liquid which are inside these vessels or inside these containers. Okay, we just imagine one of the smallest liquid column inside these inside the liquids. Then the area of this cylinder, that is having the area is A and the height of that cylinder is H. H be the heights of that cylinder which are deep in the liquid and A is the cross sectional area. Area is the cross sectional area. Then what happens? Some forces will be exerted on that weight of the liquid inside, weight of the liquid which are exerted downward. यामध्ये असलेला लिक्विड जे काही लिक्विडचं वेट आहे which are exerted some force downward directions. Weight of liquid inside the cylinder exerts some force which are downward direction, that is weight is F is equal to M into G. This is the equation number 1. Then some pressure inside the liquid column at the bottom of the cylinder. यामध्ये जे काय प्रेशर तयार होत असते हे प्रेशर at the bottom of that cylinder वर ऍक्ट होत असते. The pressure inside liquid column at the bottom of the cylinders, liquid column and at the bottom of the cylinder, then the pressure P is equals to that is force divided by area. What is the area? Force is equal to M into Z divided by area, that is small caps A. This is the equation number 2. What we know, जे काही प्रेशर आहे त्या लिक्विड कॉलमच्या इनसाइड मध्ये ते प्रेशर या बॉटम वर ऍक्ट होत आहे. ठीक आहे, त्या बॉटम वर जर एखादी फोर्स ऍक्ट होत असेल म्हणजे कशा पद्धतीने हा लिक्विड कसा आहे, हा एक वर्टिकल डायरेक्शन मध्ये आहे. त्याचबरोबर जे आपली एरियावर ऍक्ट होणारा जो काही फोर्स आहे बॉटम एरिया, हा बॉटम एरिया डाऊनवर्ड आहे. म्हणजे या कॉलम मुळे जे काही फोर्स ऍक्ट होतं वर्टिकली फोर्स ऍक्ट होतं म्हणजे नॉर्मल फोर्स ऍक्ट होतं. म्हणजे नॉर्मल फोर्स असेल, फोर्स normal force exerted on the unit area, normal force exerted on the unit area, this is the pressure. Then I will be write to this equations. We must know the definitions of pressure. The normal forces exerted by the fluids on the surface of unit area which are in the contact, this is called as pressures. And we know that the density is equal to mass per unit volume. Density, the definitions of the density, that is mass per unit volume. And just rearrange this equation, the mass is equal to volume into density. A volume ikkada multiply झालेला आहे, then mass is equal to volume into density. Then we know that the mass, the volume of this liquid column, the volume of cylinder, the definitions or equations of the volume of cylinder is equal to area into height, cross sectional area into height, that is A into H. The M is equal to, that is M is equal to A into H into rho. Then the force is equal to, what is the force? F is equal to force M into G. Then I will just multiply this equation with G. This is equal to force. Am I right? Yes. Then A H rho into G. This is the force. We know that the equations आपल्याला find out करायचं pressure म्हणजे काय, definitions and some equations of the pressures. Then pressure is equal to the force upon P is equal to force काय है, it is A into H into rho into Z. This is the force upon area, that is A. The same terms will cancel in here, that is area will be cancelled. Then the P, the pressure is equal to, it is H rho into Z. The pressure of the fluids which are exerted on the surface of that vessels, or the pressure inside the pressure of the liquid inside the cylinder exerted on the wall of that cylinder is does not depends on the mass of that liquid. Yeah, mass वर depend असणार आहे. This depends on the height of that cylinders and the density of that liquid and acceleration due to gravity on that liquids. This is all about some pressures. What is the atmospheric pressure? A atmospheric pressure is equal to the weight of the air column, weight of the vertical column of air. Consider करा या ठिकाणी आपण थांबलेला आहे. This is our earth surface. You must have seen the boats, my earth. Okay, I will be written one of the column here, just a cylinder having the unit area. Then what is the atmospheric pressure? The pressures, the atmospheric pressure, this is the weight, यामध्ये जे काही weight of the air, weight of the air in the vertical columns from the point, from any point, या point पासून जर आपल्याला एखादी atmospheric pressure of that या point जर काढायचं असेल तर या point पासून up to the top of atmospheric range of our earth. This is the atmospheric pressure. The atmospheric pressures of is equal to the weight of the vertical column, is equal to the weight of the vertical column from vertical column of the air from a cross sectional area, of a unit cross section area from that point, या point वर काढायचं असेल, from that point to the top of earth atmospheric, from the top of the earth atmospheric. here ही जी काय रेंज आहे, this range is earth atmospheric range आहे. इथून एखादा कॉलम ड्रॉन केलेला आहे आणि हे काही जी फोर्स ऍक्ट होत आहे किंवा वेट म्हणजे F इज इक्वल टू M इंटू G, दॅट इज वेट म्हणजे mg म्हणजे काय असणार, एक फोर्स आहे. देन या एअर मधून जे काय फोर्स एका पॉइंटवर ऍक्ट होत आहे ऑफ द युनिट क्रॉस सेक्शन एरियावर, त्यालाच म्हटलं जातं दॅट इज द ऍटमॉस्फेरिक प्रेशर. The atmospheric pressure is decreases when we go up. जेव्हा आपण वर जात असतो तेव्हा atmospheric डिक्रीज होते. किंवा एखादी पॉइंट जर इथं असेल तर एअर कॉलम यावर ऍक्ट होणारा फोर्स हा इतकाच असणार आहे, याच एअरचा असणार. इथं जर असेल आपला पॉइंट तर इतका पूर्ण जो काय आहे तो त्या पॉइंटवर ऍक्ट होणार आहे. म्हणजे द ऍटमॉस्फेरिक प्रेशर विल बी डिक्रीजेस व्हेन वी मूव्ह अपवर्ड डायरेक्शन्स और अवे फ्रॉम द सरफेस ऑफ अर्थ. देन द सरफेस ऑफ अर्थ have the more or most or maximum atmospheric pressure. Then the atmospheric pressure on the sea surface, on the sea level आहे समुद्र सपाटी, the atmospheric pressure on the sea level is more and this pressure is called as the normal atmospheric pressure. The atmospheric pressure at the sea level is called as a normal atmospheric pressure. In these lectures, we know that what is the pressure, the definitions of pressure, that is a normal force exerted by the fluid at rest. Fluid at rest on the unit surface area of the contact is called as pressure. Pressure having the unit, it is a scalar quantity, and the unit of pressure is a Newton per meter square or Pascal, and dimensions of the pressure is L raised to -1, T raised to -2, and M raised to 1. And we just find the pressure at a point. Pressure at a point due to a liquid column. Consider a vessel with a liquid. Consider a vessel with a liquid having the density is a rho, and the height of, and consider and imagine one of the cylinder inside that liquid having the height h and cross sectional area, that is A. The weight of that liquid of the cylinder, the weight of the liquid column, the weight of that liquid column exerted a downward force, that is F is equal to mg, and this treated equation number 1. And another one, pressure by liquid column, pressure by liquid column at the bottom of that cylinder. Pressure by this liquid column at the bottom of the cylinder is equal to P is equal to force upon area. Then force is mg, area is smallest cross sectional area, that is A. And we know that the definition of density or the equation of density is mass per unit volume. Then m is equal to volume into rho, density. Then m is equal, what is the equations of volume? The equations to finding the volume of cylinder is equal to cross sectional area into the height of that cylinder. And just use this mathematical equation here and find the pressure and dependency of the pressure of at the point which are inside the liquid. Then the pressure is depends on the height of that column, imaginary column, and the density of the liquid as well as acceleration due to gravity. And just to discuss the atmospheric pressure, a atmospheric pressure is equal to the weight of vertical column of the area, sorry, air, weight of the vertical column. The atmospheric pressure is equal to the weight of vertical column of air from the point, from that point, from that point to the top of earth. Atmospheric pressures will be extended up to the top of earth atmospheric pressure. The atmospheric pressure will be decreases when we move upward direction. The atmospheric pressure will be decreases when we move upward direction, because the air volume, the air column will be decreases. इथे जेव्हा असणार आहे या पूर्ण एअरचा जो काही प्रेशर असणार आहे, फोर्स असणार यावर एक्झर्ट होणार, बट या ठिकाणी काय असणार, थोडासा कमी कॉलम असणार आहे. Then the atmospheric pressure at the sea level is called normal atmospheric pressure. The atmospheric pressure at the sea level is called as normal atmospheric pressure. And the atmospheric pressure will be finished in the next lectures. We discuss some types of the atmospheric pressure, and we just move this cylinder up and down. Thank you.